Hi and welcome to another tutorial video. In this tutorial video, what I'm going to be doing is showing you how to do a breadth first traversal on a tree. This is one of the algorithms that we can use to visit a number of nodes in a tree in a particular order. So a breadth first search is one method, and then in another tutorial video I've covered depth first searching, which will visit the nodes in a tree in a different order. So what I've got here is a tree that we're going to do a breadth first tree traversal on, and I've also got the algorithm here. So it's going to print out the nodes in the order that we visit them using our breadth first tree traversal. So the first thing we do in our algorithm is we add to a queue the root node and mark it as visited. So for this algorithm, it's really important that we use a queue, because a queue is a first in first out data structure. So what we're doing is we can only add in elements to our queue at the end of the queue, and we can only get elements out of the queue at the beginning of the queue. And that's a really important property of the queue data structure that allows it to work with this algorithm. So we've done the first step of our algorithm here, and I'm just going to write down a place for us to output data. So we're imagining that we are the computer here. And then the next step is, while the queue isn't empty, so the queue isn't empty, we do this loop. So we dequeue a node and print it in our output. So the node we've got in the queue at the moment is A, so we're going to dequeue it and put it in our output. So we put it in our output and we dequeue it. Next of all, for all of the adjacent nodes to the dequeued node, we do these steps. So if the adjacent node is not visited, we mark it as visited and we queue it. So the adjacent nodes to A that we've got are B and C, and neither of them are visited, so we have to mark them both as visited and queue them. So we're going to start with B, we're going to mark it as visited, and we're going to add it to the end of our queue. Then for C is the other node that is not visited and adjacent to A, so we're going to mark it as visited, and we're going to add it to the end of our queue. Then we go back to the beginning of the while loop and we dequeue a node and we print it. So we're going to dequeue B, and then we add it to our output. And then for all of the adjacent nodes to the dequeued node, if they've not been visited, we mark them as visited, and then we queue them. So the adjacent nodes to B are A, D, and E. But A's already been visited, so we're only dealing with D and E here. So first of all, for D, we mark it as visited, and then we add it to the end of our queue. Then we take a look at E, we mark it as visited, and we add it to the end of our queue. Then we loop back to the beginning of our while loop, and we dequeue a node and we print it out. So we dequeue C and we print it out. Then what we do is, for all of the nodes that are adjacent to the dequeued node, if they haven't been visited, mark them as visited and queue them. So the nodes that are adjacent to C are A, F, and G. A's been visited, so for F we mark it as visited and we add it to the end of our queue, and G we mark it as visited and we add it to the end of our queue. Then we loop back to the beginning of our while loop and we dequeue a node and we print it out. So we're going to dequeue D and print it out. And then for all of the adjacent nodes to the dequeued node, if they haven't been visited, mark them as visited and queue them. Well, there aren't any nodes that are adjacent to D that haven't been visited already, so we don't need to do anything. Then we go back to the beginning of our while loop and we dequeue a node and print it out. So we're going to dequeue E and we print it out. Then, as with D, there aren't any nodes that are adjacent to E and haven't been visited, so we don't need to do anything. We go back to the beginning of our while loop and we dequeue a node and we print it out. So we're going to dequeue F and we print it out. And then finally, there aren't any nodes that are adjacent to F and have not been visited, so we don't need to do anything. We loop back to the beginning of our while loop because the queue still isn't empty. We dequeue a node and we print it out. So we dequeue G and print it out. And now there aren't any nodes that are adjacent to G that have not been visited, so we don't do anything, and our queue is now empty, so our while loop terminates and our algorithm is complete. So what that has shown us is that we've got this output here, and this output is showing the order in which we would visit the nodes in the breadth first traversal. So we visited the nodes in this order: A, B, C, D, E, F, G. So you can see, in contrast to the depth first traversal methods, where you can think of it as we're visiting sort of level 1 here, then we're visiting all of the nodes in level 2 here, and then we're visiting all of the nodes in level 3 here. So we're sort of visiting this row of nodes, if you like, and then this row of nodes, and then this row of nodes. So we're searching the breadth of the tree first, rather than the depth of the tree first, and that's where the algorithms get their name. Okay, so I hope you found this tutorial video useful, and thanks for watching.